Alright, so adding the first item, that's going to be fairly straightforward, right? I've got to create a new node, which I'm going to do, again, just do that outside of all these conditions, since all these conditions are going to rely on it. So no need to repeat code by making it in all the conditions. Node temp is equal to new node e and item. We could give it a more meaningful name, but I mean, I'm gonna use temp because it's a temporary placeholder. It's not really indicative of what's happening to it. You could give it like the name adding, but I like to just call it temp out of habit. All right, so we're adding the very first item to the list. So we're going from essentially nothing to making this node and then making it the head and the tail. So we've made the node, so now we got to make it head and tail, right? So this dot head is equal to temp. This dot tail is equal to temp, right? And that's it. That's all we have to do for that one. All right, what if we're adding a new head? All right, so now let's go ahead and use this as our basis, right? So we have currently this linked list with size 1, where we want to add a new head, right? So the same rules apply. We'll want to attach our pointers, right? So first we're going to attach this guy's .next. .next, by the way, will run on the top, and I'll have my previous's running this way along the bottom, right? And so we need to set up his .next and his .previous. Now his .next should point to the head of the list, sorry, to the current head of the list. His .previous isn't really actually going to point anywhere because he's going to become the new head. What's going to be before him? Nothing. So we'll keep that as null, right? We won't do anything with that. So we'll have to attach that, and we'll also have to make sure that this guy, and he might not necessarily be the tail too. He just happens to be in this case. But we know that this guy that we're attaching to, he's going to be the head of the list. He needs to point his previous this way. And then the final move I have to do is make sure that head gets appropriately updated and that this guy's the new head of the list. Okay? Right? So I make the guy, I attach him, I attach the .next pointers, I attach the other guy's .previous pointer, and then I update the list head accordingly. Okay? So let's go ahead and go through this, appropriately. So let's go ahead and shrink these again, and view, distraction free mode, boom. Okay. So we've already created our pointers. Okay, so we'll go over here and we'll draw it side by side. So adding a new head. So index is equal to 0. We've already made temp. That's perfectly fine. Right? So the first thing we wanted to do is we can attach temp to the head. So we'll say temp.next is going to hold the memory location of the current head. Okay, that's a no-brainer. And we know, and one of the nice things is that we know that the head here is not going to be null because of this if size is equal to 0 clause. This size equal to 0 clause really helps make sure that basically we're not going to deal with any null pointer exceptions or have to try to handle any weird null pointer exceptions. And that's the reason I do my add method with these 5 scenarios. It prevents you from having to bash your head against a null pointer exception. Okay, so we attach ourselves to the head of the list. Okay, the next thing we have to do is have the head point backwards to the what will be the new head of the list. We got to point this needs to point backwards here. Now this isn't his .next pointer, this is the head's .previous pointer. So what we're going to say is that the current head's previous is equal to temp. Makes sense? This guy is pointing backwards. Okay, now we just have to update head to to represent which node is now in front. Head is equal to temp. Right? Now this guy, and so now, right, this takes the memory location of this node over here and stores it in the variable head. Okay, so that's adding a new head. Adding a tail is pretty much the same exact thing, but in reverse, but we flip things around, right? So here's our new temporary node over here that we're adding, right? Okay. So first thing we want to do is attach this guy. Let's think about his .next and .previous pointers. He doesn't have any .next. He doesn't have any .next to attach to, right? There's nothing for him to point to, right? Nobody behind him. So that's just going to remain null. We don't have to manually set it. It just will be null. But to attach to the tail, we have to point backwards. So temp.previous is equal to tail. Makes sense. And of course, the tail will want a way to get from the old tail to the new tail. So tail's .next pointer needs to be created and point to this guy. Tail.next is equal to temp. All right, and then tail is equal to temp. And that, again, is it. That is all you need to do. And so now we have this node. Now, adding, as you might imagine, for any other case, it's going to look slightly messy, because when we add a new node, we're going to have to move a lot more pointers around, right? But it's going to be it's not going to be too difficult. But it is worth doing in its own video, especially since now we definitely want to test out this code by printing it out. So I'm going to go back to the other linked list class. Boom. Let's go ahead and grab the toString method from it. Steal. Right. And now, what are we overriding our parents, right? Let's go ahead and make a public static void main. Okay. Doubly linked list of string L is equal to new doubly linked list. And let's go ahead, and we actually do have enough to finish the other add method, which we do by just simply switching this to a return true and a add size item, just like we did last time, right? L.add a L.add B, and the only indices we can add are to the end or to the front right now. L.add 0 F, and so now we run this one, and please work, please work, please work. Oh, right, you print out our list at the end. Didn't crash there, so that's promising, right? FAB, right? We add A to the end of the list, B to the end of the list, and then F to the front of the list, and so it looks like we're good. So I'll continue on the next video on this very last case for adding.